All right, everyone, this is section 2.8, modeling and variation. So as you can see here, there's quite a bit of vocabulary up top. We're dealing with 4 different types of variation. Now, variation describes a relationship between 2 variables. We can see here that we have 4 different types: direct, inverse, combined, and joint. And if you want to take a minute to write down all of these definitions, I'm going to talk through them and leave it on this screen here for a minute. But if you do need a little bit extra time, please feel free to pause the video. So we're going to be dealing with first direct variation, and this is described with the formula y equals kx, where k is what we call the constant of variation. You may recognize this in a problem as with language like y varies directly with x, or y is directly proportional with x. These can include exponents. Most often, the first variable, y, will not include a variable, but then we may see something like y varies directly with the square of x. And you can see we would set that up as y equals k times x squared. We also will see inverse variation. Instead of multiplying k times a variable, in this case you would be dividing k by a variable. Combined variation is basically direct and inverse variation occurring at the same time. Basically, we multiply by one variable and divide by the other. And then finally, we have joint variation, where we are directly varying with 2 variables. You can see our formula there is y equals some constant k times x and another variable z. So I'm going to let you guys just digest that now and see how we treat each of these. The good news is, while we have these 4 different types of variations, we really solve them all the same way. So to solve any of these problems, we want to choose the correct variation setup, right, based on the context of the problem, whether it's direct, inverse, combined, or joint. We are going to use the information to solve for k. Now, just a quick note here, k is a constant, in that once we find k, it is the same for all problems and for all situations that we have. Once we have that k value, we now have less unknowns in our equation, and they'll usually give us a second question to help us solve that equation. So I think once we get into some examples here, you'll start to see this process. But in every case, we're going to choose an equation setup. We are going to solve for k, and then we're going to use k as part of a new equation to solve for some unknown variable. So let's take a look at example 1. In example 1, and these problems will all be word problems, so just fair warning on that. In example 1, they tell us that the volume of blood in a person's body directly varies with their body weight W. So I'm going to set this up. I'm going to say that variable B equals some constant times W. I've made that decision because they are telling us that we vary directly. So our first variable is B, and our second variable is W. They give us a situation. A person who weighs 160 pounds has approximately 5 quarts of blood, and that's going to allow us to find our K value. Our K value here will be 5 over 160, or simplified 1 over 32. Now that K value is fixed, it is a constant value, so we can rewrite our equation B equals 1 over 32 times W. And now they tell us some other information, right? They say they want us to estimate the number of quarts of blood that a person who weighs 200 pounds. Well, now we only have 2 variables. I'm going to figure out the amount of blood B, and the way that's going to work is 1 over 32 times the weight given, in this case 200. I'm going to calculate that, and I will find my B value, the amount of blood for a person who weighs 200 pounds, to be 6.1 quarts. So the first thing I did, I set up my equation. The second thing I did is I solved for k, and then the third thing, I solved the equation using k. Let's look at another one. In example 2 here, they tell us that the number of houses that can be served by a water pipe. So let's say the number of houses can be, varies directly. So we're going to say k times the diameter of the pipe. But again, we just got to read carefully here, the square of the diameter. So not just k times d, but k times d squared. From here, the equations will behave relatively similar, right? They tell us that a water pipe that has a 10 centimeter diameter can supply 50 houses. So 50 equals k times 10 squared. Well, we can see here that 50 will equal 100 times k. So k will equal 50 over 100, or 1/2. Now that we have k, we can use it. So h equals 1/2 the diameter squared. They tell us what size pipe is needed for a new subdivision, including that has 1,250 houses. So 1,250 equals 1/2 the diameter squared. Well, that means that if we were to multiply both sides of our equation, that 2,500 would equal our diameter squared. So our diameter will be the square root of 2,500, or 50 centimeters. Again, same 3 steps. Set up your equation, find k, and then use k to solve the problem, the question asked by the problem. We can even kind of think about this. Every sentence in the problem kind of leads us to a different step, right? The first sentence allows us to pick our variation. The second sentence allows us to find k. And then the third sentence in the problem asks a new question that we'll have to use k to solve. We're going to go about these last 2 problems a little bit differently. I'm going to ask you guys to, pause the video and try to work this one out on your own. You want to read carefully to pick the correct variation, set up your equation, solve for k, and then use that information to answer the question in the problem. I'd recommend you pause here and try examples 3 and 4 now. I'm going to do the same. I'm going to pause and work these out, and then we'll kind of take a look and see how they look. We'll take a look at these problems and see how they came out. All right, let's see how these problems went. So in this problem, they tell us that the length of a violin string varies inversely with the frequency of its vibrations. So with the inverse setup, I must be dividing by k with my second variable. So they tell us that a violin string that's 8 inches long vibrates at a frequency of 640 cycles per second. That information helps us find k. Now we use that k value to solve the question at hand. What is the frequency of a 10-inch string? Well, I plug that 10 in for L, and I can solve for F. I found that the frequency occurred at a level of 512 cycles per second. Again, just to repeat myself here, we're going to set up a variation equation. We're going to use the information given to find k, and then we're going to use our new information involving k to solve the equation at hand. Here on number 4, they tell us that the number of minutes needed to solve an exercise of variation math problems varies directly as the number of problems. So that's where the time varies directly, and inversely with the number of people. So the inversely with the number of people, that goes in our denominator in our setup. Again, we're going to use all that information in the next sentence. It takes 4 people 32 minutes to solve 16 problems. That helps us find k, right, our constant of variation. Now we're going to use k To figure out how many minutes it will take 8 people to solve 24 problems, we can see that we're just solving a simple equation for a specific variable. In this case, t equals 24 minutes. We have one more problem I want to look at together. This is example 5. They tell us that the volume of a cone, V, varies jointly with its height and the square of its radius. So there's some constant that gets multiplied by its height and its radius squared. So just make sure you're reading carefully here, right? The square of its radius means that we have to square that R value. Oh, now we're going to go ahead and find K. They tell us a cone with a radius of 6 and a height of 10 has a volume of 120 pi cubic feet. That means that K times 360 equals 120 pi. That means our K value is pi over 3, or 1/3 pi. Now that we have a K value, we have a volume formula. It is going to be height times radius squared all over, we should multiply this times pi, all divided by 3. If you think back to our geometry classes in our history, our mathematical lives here, this formula should seem familiar. The volume is represented by the radius squared times pi times the height divided by 3. Well, now we can find the volume. They want us to find the volume when we have a radius of 12 feet and a height of 2 feet. So that's going to be 2 times 12 squared times pi, all divided by 3. This here will be 288 pi divided by 3, or 96 pi feet cubed. Big idea here, no matter what type of variation we're dealing with, we're going to follow the same 3 steps. We need to pick a variation equation. We need to use that variation equation to find K. And then we're going to use our new equation that involves K, our constant of variation, to help us solve a different situation where we're going to plug in for one or more of the variables and solve for the remaining one. That's it, guys. Thanks for your time.